We spend about a third of our lives sleeping, but how much do we really know about sleep? It is not just a period of time when our eyes are closed and we are moving or talking. There are 4 distinct stages that you go through every night, each with their own unique effects on your brain and body. What's more, your sleep has a profound effect on your mood, memory, creativity, metabolism, and even your life expectancy. In this video, we will be taking an in-depth look at what happens to your brain and body when you sleep so you can get a better understanding of one of life's most essential activities. First off, let's take a look at how brain activity changes as you fall asleep. When you first start to doze off, your brain starts to slow down its activity and enter the first stage of non-rapid eye movement, sleep, also known as NREM1. This is a transitional phase where the body begins to relax. Although this stage only lasts a few minutes, it's easy to wake someone up who's in this stage of sleep. As the brainwaves continue to slow down, you enter NREM2, which makes up about 45 to 55% of your total sleep time. This is a deeper stage of sleep than NREM1, but if you were woken up at this point, you would still feel pretty refreshed. The brain still responds to noises and other external stimuli, although you may not remember doing so. After passing through these 2 stages of NREM sleep, your brain will begin to enter the deepest stage of sleep, NREM3. This is a stage where brain activity is the slowest and delta brain waves start to appear. This is also the most restorative stage of sleep, which means that it plays a crucial role in the healing process. If you happen to be woken up during this stage, you'll probably feel groggy and disoriented for a few minutes before you can fully wake up. Some experts believe that NREM3 is essential for restoring and rejuvenating the immune system, while others believe that it helps to lower inflammation throughout the body. Unfortunately, people over the age of 60 tend to experience less NREM3 sleep, which might explain why older adults are more susceptible to illness. After finishing a full cycle of NREM sleep, your brain will begin to rapidly shift into the 4th and final stage of REM sleep. This stands for rapid eye movement, which is a reference to the quick movements of the eyes that occur during this stage. During REM sleep, your brain will become more active and begin to resemble brain activity that occurs when you're awake. You're also much more likely to experience dreaming during this stage, which could be one of the reasons that REM sleep is important for emotional processing and mental health. This is because dreams have been found to contain material that reflects unresolved emotional issues, conflicts, and experiences from the previous day. Studies suggest that REM sleep deprivation can lead to an increase in negative emotions, such as anxiety and depression. While REM sleep has been found to be necessary to alleviate emotional tension, so those are the 4 stages of sleep that your brain goes through every night. But what actually happens to your body during this time? One of the most noticeable things that happens to the body when you sleep is that your muscles become. This is a phenomenon known as atonia, which occurs during both REM and NREM sleep. Although atonia is present during all stages of sleep, it's especially prominent during REM sleep, which is why you never move or talk while you're dreaming. The purpose of atonia is believed to be keeping you still so that you don't hurt yourself or make noise that will disturb others. However, sometimes this mechanism fails, which can result in something called sleep-related movement disorder. This is when your body involuntarily moves or twitches while you're sleeping, which can often cause you to wake up. There are several different types of sleep-related movement disorders, including sleep myoclonus, which causes brief muscle jerks, and restless leg syndrome, which causes uncomfortable sensations in the legs. Another thing that happens to your body when you sleep is that your heart rate slows down, which allows your heart to relax and recover. On average, your heart rate will drop by about 25% when you fall asleep. This is because your parasympathetic nervous system becomes more active when you're sleeping, which helps to regulate bodily processes such as digestion and sexual arousal. Interestingly enough, having a slower heart rate while sleeping has been linked to a decreased risk of cardiovascular disease. In addition to slowing down your heart rate, sleep also plays a critical role in lowering your blood pressure. A study published in the Journal of the American Heart Association found that people who slept for 6 hours or less per night were 28 more likely to develop hypertension than those who slept for 7 to 8 hours per night. While it was previously believed that sleep helped to lower blood pressure by allowing your body to rest and relax, newer research suggests that it's actually due to nitric oxide. Nitric oxide is a molecule that helps to relax blood vessels and improve blood flow. Studies have found that levels of nitric oxide in the blood increase while you're sleeping, which could be one reason why getting enough sleep is important for cardiovascular health. Next, let's take a look at what happens to your brain while you're sleeping. As mentioned earlier, there are several key differences in brain activity between the different stages of sleep. For example, NREM sleep is associated with slower brain waves and increased delta wave activity, while REM sleep is associated with faster brain waves that resemble brain activity during wake. These different stages of sleep serve different purposes and are controlled by different parts of the brain. For example, the suprachiasmatic nucleus, or SCN, is a group of neurons in the hypothalamus that helps to regulate your circadian rhythm. The SCN receives input from the retina in the form of light and uses this information to help synchronize your sleep-wake cycle with the 24-hour day-night cycle of the planet Earth. Another structure that plays a critical role in sleep regulation is the pons, which is a part of the brainstem that contains a group of neurons called the pontine tegmental group, or PTG. The PTG is active during REM sleep and is thought to be involved in the generation of REM-related brain activity. As you can see, there are many complex processes that occur in the brain when you're sleeping. But what is the purpose of all this activity? To put it simply, sleep helps to restore and rejuvenate your brain, so that you can be alert and focused when you reawake. One of the ways that sleep helps to achieve this is by removing waste products from the brain. During wakefulness, your brain produces a number of waste products, including carbon dioxide, water, and adenosine. As these waste products accumulate, they begin to slow down brain activity, which can lead to fatigue and drowsiness. However, during sleep, your brain is able to clear away these waste products, which helps to restore brain function and improve alertness. In fact, researchers have found that even a single night of sleep deprivation can lead to a buildup of waste products in the brain, which can impair cognitive performance. In addition to removing waste products, sleep also helps to strengthen connections between neurons in the brain. This process is known as synaptic plasticity and is thought to be essential for learning and memory. During wakefulness, your brain forms new synapses between neurons when you learn new information. However, these synapses are weak and inefficient, which can lead to forgetting. During sleep, your brain strengthens these synapses, which improves memory and makes it more likely that you'll retain the information that you've learned. In fact, studies have found that sleep deprivation can lead to significant impairments in memory and cognitive performance. Another important function of sleep is that it helps to consolidate memories. This is the process of transferring new memories from the hippocampus to the cerebral cortex, which makes them more stable and less prone to forgetting. Research suggests that sleep-dependent memory consolidation is important for both short-term and long-term memory. Last but not least, let us take a look at some of the common sleep disorders that can disrupt the sleep cycle and what you can do to prevent them. The most common sleep disorder is insomnia, which is the inability to fall asleep or stay asleep. Insomnia can be caused by a variety of factors, including stress, anxiety, depression, and medical conditions. Fortunately, there are a number of things that you can do to improve your sleep and reduce your risk of developing insomnia. First, try to establish a regular sleep schedule by going to bed and waking up at the same time each day. This will help to regulate your body's natural sleep-wake cycle. Second, make sure that your bedroom is dark, quiet, and cool. These conditions are optimal for sleep and will help you fall asleep faster and stay asleep longer. Finally, avoid using stimulants such as caffeine and nicotine before bed, as these substances can interfere with the sleep cycle and make it difficult to fall asleep. Another common sleep disorder is sleep apnea, which is a condition characterized by pauses in breathing during sleep. Sleep apnea can be caused by a number of factors, including obesity, large tonsils, and neuromuscular or endocrine disorders. Fortunately, there are treatments available that can help to manage sleep apnea, such as continuous positive airway pressure, or CPAP. So there you have it, guys. Those are some of the fascinating things that happen to your brain and body when you sleep. Hopefully, you learned something new and will be able to appreciate the importance of sleep the next time you feel like staying up late. And if you did enjoy the video, please make sure to leave us a like and subscribe for more science videos. Thanks for watching.